For this experiment, you will need a Planck's constant determination apparatus, a 9-volt battery, a number of lead wires, and to measure the voltage across the LEDs, a voltmeter, and to measure the current going through the LEDs, an ammeter. Now, this Planck's constant determination apparatus consists of 7 LEDs. Different LEDs can be selected by using this switch, and there is a variable resistor here that can vary the voltage going to the LED. Now, for trial 1 of this experiment, we select the blue LED, which, according to the manufacturer, emits photons of a wavelength of 470 nanometers. Now we adjust the voltage across this LED by using a variable resistor, and as you can see, as we decrease that voltage, the LED gets dimmer, and we're watching the ammeter and making a note when the ammeter's current first goes to 0. So we're getting close here, and the voltage on the voltmeter is 1.94 volts. Now for trial 2, we select a different LED, a green one, and again, according to the manufacturer, this LED emits photons that have a wavelength of 505 nanometers. And again, we adjust the voltage to this LED so that the current on the ammeter just goes to 0. We're getting close here. And the voltmeter reads 1.78 volts. And we'll just keep selecting different LEDs and measuring that threshold voltage. Now these last two LEDs are in the infrared region. This one here has a wavelength of 880 nanometers. And again, we adjust the voltage. Now here's the last trial with an LED in the infrared region. And again, according to the manufacturer, the photons emitted by this LED are 940 nanometers. And again, we adjust the voltage across this LED and watch the current and see when the current first goes to 0. So for this LED, the voltage measured by the voltmeter is 0.54 volts. Now with this information and the worksheet that accompanies this video, plot a graph of the minimum energy of the electrons in the LEDs as a function of the frequency of the photons that they emit, and from this graph determine Planck's constant.